Section 2.1 was input and output values, and we're going to build on that with domain and range in section 2.2. Let's start with the definition. If y is equal to f of x, then the domain of f is the set of input values. So this is a set of x values, which will give a meaningful output value. All right, so let's talk about what that means. Consider the function f of x is equal to 1 over x. When we think about the x values we can plug in there, we could put a 2 in, we get a half, we could plug in a -4, we get a -1/4. The one number we can't plug in is x is equal to 0 because that would make this thing undefined. You're not allowed to divide by 0 in math. And so we would say that x equals 0 is not in the domain because it doesn't give us an actual meaningful output. All right, the range of f is the corresponding set of output values. So these are all the y values we would get by plugging our domain in, our x values, into our function. Right, let's look at a practical example of this. The number of gallons of paint needed to paint a house depends on the size of the house. A gallon of paint typically covers 250 square feet. Thus, the number of gallons of paint, which we'll represent with n, is a function of the area to be painted, A, and that is in feet squared. We'll write n equals f of a as our function notation. This problem has some practical limitations on the domain and range. What would be a reasonable domain and range for this function? So let's start with the domain. Our input, or our independent variable here, is the area of the room or the area of the house that needs to be painted. So what numbers would seem reasonable? If I needed 500 square feet painted, that seems fairly reasonable. What about 2,500 square feet? That's probably pretty reasonable also. What about -100 square feet? Yeah, that's going to be a problem, right? We can't have a room or a house with a negative square footage. That doesn't make any sense. So we know that the area, which we're representing with that letter A, needs to be bigger than 0. Okay, and that will be our domain. We know that it's not infinite, but A can be as big or as small as we need it to be, as long as it's a positive number. All right, and then our range. So our dependent variable is the number of gallons of paint. So that was represented with the letter N. And what would be reasonable here? So again, it doesn't make a lot of sense to have negative gallons of paint, but positive gallons of paint seems to make some sense in order to paint that room. So we would say N is greater than 0.